I'm Andrea Fabry. I'm a senior data engineer at VTS. Unlike Simple Business, VTS is at the very beginning of its DBT journey. We are currently in the process of running an evaluation on adopting DBT and adding it to our data stack. So I am here to tell you about this process, and it actually will pair really nicely with Ben's presentation, because his was very technical and mine is all about the code. He told you all about how they got DBT up and running on their users' computers. I am here to tell you how to set up your DBT project for success once it's up and running on your computers. So in order to do this, I'm gonna tell you a little bit about VTS. Then I'm going to share our evaluation criteria for the proof of concept that we're running. Then I'm going to talk about the unit of work that we selected for this 2-week evaluation. I'm going to talk a little bit about the prep work that we did and that I would highly recommend, as well as make it optional for running a successful proof of value. And then I also have a couple of slides with resources and checklists and artifacts and other steps to a successful POC. Okay, so VTS is, in a nutshell, is a unicorn in the proptech space. Our mission is to be commercial real estate's modern operating system, the place where deals happen and real-time data comes to life. So yes, data is extremely important to us. We have been expanding our data products, and we just introduced commercial real estate's first industry index, which has been quoted by the Wall Street Journal and Reuters as well. So yes, data is very important to us. Yes, we're expanding our data products. Yes, we're expanding our data teams. We're hiring for data engineers, data scientists, business analytics team. And yes, we're a global company. And yes, we have an office in the UK. So all these things are yes. The no part is no, we don't have DBT. If you walk into our office, unlike if you walk into Simple Business, if you walk into our office, you will not be onboarded onto DBT. So that was one of the very first questions I asked from Claire. I was like, oh, would it be okay for me to talk about DBT when we're not using it, but we're at least running a POC? And she said, please don't call it a POC. POC stands for person of color. So we prefer to think of it as a proof of value. And in hindsight, that was a blessing in disguise, because concept is very abstract and vague. But once I started thinking of it in terms of proof of value, it was really, okay, we're evaluating this tool. Every tool brings lots of cool features as well as added complexity to your stack. What is the particular value that we're seeking that makes that pain worth it? So we thought about what is the value that we're looking to add from DBT. That for us is we want to write great code. So that's sufficiently vague. What does great code mean? I just copied and pasted this nice laundry list from Randall Hyde's book, Write Great Code. And these are basically the attributes of great code that we then took and organized into 4 major themes, because these attributes were all about software engineering. And we wanted to ask, what does great analytic code mean? And in particular, what does great analytic code mean to us? So for us, it actually means 4 things, right? 1, we want code that is easy to read and rewrite. What does that mean? Usually it means that the code is well formatted and easy on your eyes. And then also it is easy to read and understand what's going on, because it follows some sort of design pattern. And that design pattern is your shortcut of, oh, wait a minute, I know what's going on. This is doing this. Design patterns also help with our second criteria, which is we want to write performant code that uses CPU, memory, system resources, Snowflake credits, whatnot, efficiently. And we're actually in Looker. If you have used Looker before, that Looker gives end users this fantastic flexibility in terms of writing their own queries and self-serving with analytics. At the same time, that means that you have very little control over what particular queries are going to hit your database concurrently at any given hour of the day. So for us, the performance is really important, and we need something that plays nicely with Looker and that endless flexibility. And then in addition, we want our end users to be able to explore our data with confidence and ease. And confidence just means the code is well tested, and ease means it is well documented and easy to use. So we started off this proof of value with the question, how can DBT help us write modular, performant, tested, and well-documented code? So next step, after we came up with this evaluation criteria, we selected a scoped unit of work that really fits within that 2-week trial that you want to be doing for your proof of value. And it really helps you evaluate various aspects of what you're looking. For us, the scoped unit of work that we selected is one business metric, which is modeled in one star schema, which translates into one explore in Looker. So the star schema is the basic unit of the Kimball style dimensional model. We use Kimball's dimensional modeling. We use the agile take on it. It's not the only dimensional modeling school out there. Any sort of design pattern will give you, any sort of dimensional model, it will give you design patterns. We just like Kimball. So a star schema basically consists of a fact table that calculates one metric and a number of dimension tables that help describe that metric in more detail by adding the who, what, where, when, why, and how. And the reason why we like the Kimball side dimensional model is that actually it really plays to the strengths of both DBT and Looker. And the way it does that is it helps you materialize your computationally intensive queries in the fact tables while retaining that self-service flexibility of Looker with the dimension tables. So in this particular case, for instance, if you look at what we selected for this particular proof of value, it brings together deals data with dates, because we're looking at it on a daily basis, so the dates utilities table, and it brings in event data that shows when and how these deals were updated. And then we do all sorts of calculations. We join these together. We do all the calculations that help us work with various measures in Looker. And then we give our end users the flexibility to slice and dice this based on, they can look at these metrics in terms of deal sizes, deal types, deal location, user persona, user name, user location, etc., etc. And this particular, this star schema translates into one lightweight explore in Looker with one-to-many relationships on primary and foreign keys. And this particular setup is actually the one that both DBT and Looker recommend. And this particular setup is the one that helps you take advantage of the symmetric aggregate algorithm that Looker has underneath the hood, optimizing explores. Okay, and by the way, the star schema is called the star schema because if you have a couple of dimension tables, then it really looks like a star. Ours is more like a little robot with two hands or something like that. Okay. Next up, once we had the scope to work, we actually did a lot of prep work. And the one prep work that I really recommend is doing some sort of data profiling on your source tables. Because if you go into the proof of value with the data profiling, that really helps you tease out all the cleaning steps and transformation steps that you need between your raw data and your Looker Explore. And it helps you think about the various steps that you need to validate along that journey and the various steps that you need to document in DBT. So I really, truly recommend that you do some data profiling before you actually do your proof of value. Another thing that I recommend, but is optional, is a little bit of thinking ahead of time. Once you're actually in DBT and you're writing code, you will be facing a lot of questions. Where does my bronze, silver, gold data go? What do I call my folders? What is my naming convention for files? All these kinds of things. I have to tell you, I just did this yesterday and I went back and forth on a lot of things, and it's added complexity that you don't want to add to your project. So I would strongly urge you to get a couple of documents ready before you actually go into the proof of value. I actually set up a repo, and that's where I put all these things ahead of time. Okay, so in summary, these were basically the steps that we followed. We defined our evaluation criteria, which for us, we wanted to evaluate how DBT can help us write modular, performant, well-tested and well-documented code. Step number 2 was select a scoped unit of work. For us, this was the STAR schema, which is a design pattern. It helps us write modular code that we can reuse, and it helps us write performant code that plays into the strengths of both DBT and LookML. Step 3, do the prep work if you can, if you do have time. Highly recommended is data profiling so that you can take advantage of the data testing and documentation capabilities of DBT. And the optional one is have some other documents ready, from SQL guidelines to naming conventions, DBT project structure. All these kinds of things will just make it an easier experience. And then step 4 is really like the Nike commercial, just do it. So that was basically my presentation. I'm happy to take questions. I also have some resources here, which I can share in the DBT Slack channel.
Thank you so much, Andrea. It's very exciting. I don't think you answered like my big question here, which is, did you see the value you were looking for?
We're in the middle of it still.
We're in the middle of it. Okay. Yeah, I didn't see any other questions yet coming from Slack. If anyone has any, definitely drop them in. But I've got a few that I didn't have a chance to write. I'm curious, how many people from VTS have been involved in this process, in the proof of value?
We are in the setup, just the 2 of us, on 2 data engineers, and then we are actually doing internal demos for our business analysts, data scientists, and then to a larger engineering audience so that they can all evaluate DBT for various internal use cases other than analytics engineering.
Cool. And then how, in terms of making the decision, does any one team own, or do you have it like a democratic process? I'm curious, like as you get feedback from different groups who have stakes.
This is actually a decision that's going to be made locally on analytics engineering, since it's so well suited for the analytics engineering use case, and that's what most of our use cases are right now. And then we're going to, but Obviously, we're taking feedback from all the other teams, engineers, as well as business analysts and data scientists will definitely weigh in.
That's great. I've led this process on the other side as well, like prior to joining Fishtown, and it was much more, I don't know, challenging, we'll say. There were a lot more people involved, but it was so great to hear you walk through this because it really does. Everything you shared here resonates so strongly with me in terms of starting from a really clear space, making sure that the data you're working with, you have a deep understanding of it, what you've defined what value looks like ahead of time, like what you're solving for. So I have high confidence here that you'll convince them.